next question asks what is. So let's say question 2. So first let's look at what an absolute function actually is. So an absolute function, or an absolute value rather, is the notation that shows that the value will always be positive in magnitude. Looks kind of like that, right? So that shows that x, or that x with this notation will always be a positive value, positive x, okay? Well, I guess I should say the value inside of the notation can be negative, x can be negative, but the result after the absolute value brackets are applied is a positive number, all right? So we're looking for the derivative of that. So we're going to move this example here. So this notation can also be written as the square root of x squared, okay? You can also write that, as we know, the square root can be written as an exponent of 1 over 2. And that will help us when taking the derivative, because it's a little bit easier to see as an exponent, because we know this is the power rule, or sorry, yeah, the power rule, but also the chain rule, because we have a power on the outside plus a function on the inside of the brackets, okay? There we go. So applying what we know about the chain rule, we're going to take the 1/2 out in front, keep the function in the brackets as is, and then go take the exponent, which is 1/2 minus 1. That's n minus 1 for the exponent. And then, using chain rule, we're next going to take the derivative of the function on the inside of the brackets, which in this case is 2x. All right, these cancel out, and the 1/2 minus 1 is minus 1/2 times x. Since it's minus, you can also write it in the denominator, and that will make the exponent now positive, x squared 1/2. Or, of course, you can write the 1/2 as a square root again, so you can visualize that. And as we stated at the beginning of this question, that is the same thing as the absolute value. So the derivative is equal to x over x, the absolute value of x. The derivative of the absolute value of x is equal to x over the absolute value of x. Okay. Going through this solution here, they came up with the same thing. So we're good to go. Just going to leave a comment. Oops, that's correct. And we can move on to the next question.